So this is question 71 on page 530. This is the question that I thought was really interesting, but I couldn't think about how to solve it at the time. So when thinking about this a little bit longer, one of the things that you notice is that this angle right here, if you were to draw a line between that angle and through the two circles, this angle is bisected. So what we can do to start off with is say that theta equals 2 beta. And beta is just half of theta. So then we also notice that this ends up being a right triangle, where we have two right triangles. We have one right triangle with a opposite of 4 and the hypotenuse of this unknown x. So we have one triangle of opposite 2 and the hypotenuse x, which equals sine of beta, and that also equals the same triangle of opposite 4 over x plus whatever this length is, which is going to be 4 because this is the radius of the circle, and 2, so we end up having a 2 plus 4 plus x value. So it is going to be 4 over x plus 2 plus 4. And then we can set these equations equal to each other. So we have 2 over x equals 4 over x plus 6. If we now solve for x, you multiply on both sides, you end up with 2 times x plus 6 equals 4 times x. I got that by cross multiplying. I distribute. I have 2x plus 12 equals 4x, 2x equaling 12, and x equaling 6. So now that I know that x equals 6, and I know that sine of beta equals 2 over x, I can now say that sine of beta equals 2 over 6, which now equals 1/3. And if I do a arcsine of 1/3, I end up with arcsine of 1/3 equals 19.5 degrees. And now, if I were to find out what theta equals, which is just 2 times beta, I end up with theta equaling 2 times 19.5 degrees, which equals 38.9 degrees. And that's how you solve 5 page 530, question 71.